Good morning. My name is Samantha Riles, Communications Officer from Communications Officer from Sugar Research Australia, and I'd like to welcome you to today's webinar. This webinar is the second in a three-part series focusing on biosecurity. I will put details for the third upcoming webinar in the chat box. Our next webinar will focus on pests, major threats, and current research. Our presenters for this series of webinars are Dr. Rob McGarry, Dr. Nicole Thompson, and Dr. Kevin Powell. In today's webinar, Dr. Nicole Thompson will be speaking about diseases, major threats, and current research. Please note that today's meeting is being recorded. We encourage you to keep your microphone on mute to keep the background noise to a minimum. I will be assisting as co-host to ensure all runs smoothly. If you are having any technology issues, please send a message in the chat box, which is located on the menu bar of your screen. I have included details in the chat box of how you can dial in via phone if you are experiencing computer issues. We encourage you to take an active part in today's meeting by asking questions. You can do this at any time throughout the meeting by typing your question into the chat on the menu bar. I will ask these questions at the end of the presentation on your behalf. If it is easier for you to ask your question verbally than to type in the chat, please unmute yourself. I'd now like to hand over to our speaker for today, Nicole Thompson.
Thanks, Sam, and welcome everybody to the second in this series. So I'm going to talk about the current sugarcane diseases and future threats. And really the theme of my talk is really preparation is key. As some of you may know, I'm located at our beautiful Woodford site, which is the pathology farm. So the outline of my presentation, first I'm going to be talking about how we control major diseases in Australia, using a few of the major diseases as examples. Then I'm going to be talking about how we are preparing for the next threats, using some examples of high priority pests and diseases, mainly for all of the diseases actually. And then I'm going to be interweaving in that some future directions and research which we have ongoing or just completed in these areas. So for people who attended last week's seminar 2 weeks ago, this may seem a little bit familiar. I have stolen 2 of Rob's slides because they provide excellent examples for me to go through in this presentation. So what I want you to notice in this slide is that we have a large number of diseases. Okay, so I want you to notice that we do have a large number of diseases, many of them. And this is a pretty good, snapshot of major diseases or diseases that have caused problems in the industry in the past. But what I actually also want you to notice is the fact that a lot of these diseases, they do start in a region. Some, like smut, will go everywhere across the industry, and others, such as Fiji leaf gall, they'll end up being concentrated in one area. And of course, an important point is that a lot of this was related to overgrowing or reliance on 1 or 2 major varieties. The other thing that is also of interest in this seminar is that the time periods, they do overlap. So you don't always get just one disease to look at. Sometimes things are a little bit more complicated. This is the other slide that I have stolen from Rob, from Rob's presentation. Again, it's that list of diseases, but in this slide, the important things for this seminar to note is the fact that a lot of these diseases, we look at for resistant varieties as being the way that we do control of those diseases in the long term. So it's not just of resistant varieties, of course. We have looking at clean seed programs and other hygiene principles. I'm just going to try to turn my laser pointer off. How's that? Okay, so this is another slide that is kind of pretty common around the sugarcane industry, and you may wonder what it's all about. So this slide I'm going to use to demonstrate what I'm going to be talking about during this presentation. So this slide is a map of Queensland, obviously, and you can see it's been separated into sugarcane biosecurity zones. By the end of this talk, you should know why these zones are where they are and what significance they have. So what I'm going to be talking about using examples, I'm going to be looking at diseases that are found in all regions, diseases that are found in specific regions. Either they have a natural barrier, like the climate is different, or the weather is different, or there is just other natural barriers in cropping areas. And then I'll also talk about these quarantine barriers, these lines in between the biosecurity zones. I'll also touch on niche areas. So by niche areas, what I mean is an area which is got a specific microclimate or specific soil type or something specific that is for that particular area. This is something you may not have seen before. These are the lines that I mentally draw on the map. So these red lines indicate the far northern biosecurity zone, which we will come back to later in the talk when we talk about exotic threats. The far northern biosecurity zone is the closest area to our near neighbours in the north of Papua New Guinea and Indonesia. And obviously this is where a lot of threats come from. So this sits in its own biosecurity zone. And then you can see I've got two other really big red lines on there. And this is kind of, will come apparent later on, but these are movement lines beyond which you need to have permission from the Queensland government, specific permission with disease testing to move material from the south to the north. I'm going to also talk about major diseases, minor diseases, and leaf diseases. Now, as you probably would remember from Rob's talk, any of these diseases can become major diseases, but we're just going to be talking about what they are in this particular talk. And of those, we're talking about whether they are spread in planting material, so in stalks or in sets or billets, whether they are spread by wind or rain or flood, or whether they are spread by an insect vector. So I'm going to be talking about four kind of major diseases that we have. And the first one of these is one that should be very common. You probably have seen this around, sugarcane smut. So sugarcane smut is a fungal disease. It affects the growing point of the cane. And as you can see on the image on the right, you can get every growing point turning into a whip. And when that happens, you get no cane at all. Sometimes you can get more minor infections where they start with just a few whips here and there, and then they turn into major infections. And sometimes they, the cane will be relatively tolerant of having infections. Smut, this was an incursion in 2006. This was the most recent disease incursion, and Rob did talk about this in his presentation a few weeks ago. But it spread to all growing regions in Australia within 5 years. So this was pretty devastating to the industry. However, it probably wasn't as bad as what it was predicted to be if you had gone back 10 years prior. Because about 10 years prior to the incursion, that is when SRA or BSES at the time was starting to look into how do we prepare for sugarcane smut. It was obvious that this was going to be the next threat because it was in every growing area, every major cane growing country in the world, bar 3. That was Australia, Papua New Guinea and Fiji. So it was inevitable, especially when it started, when it was found in the Ord region in the late 90s. So at that time, started some overseas research. We're looking at variety resistance and doing some surveillance to make sure we could know where it is and how long it would be until it got in. One thing that some of you may remember is that when smut first came in, Our biosecurity zones, which were on that first map, they actually changed. So these are not written in stone. They are written in legislation, but they're not written in stone. So these zones did change. We had a 2A and a 2 and a 2A, I think, at that time to manage material movement, because smut is a systemic disease, i.e. it is in the planting material. So how did we manage smut? Well, the first thing was obviously getting these resistant varieties. So as Rob talked about last week, there was a big push. We did a screening of our major varieties in Indonesia, and then screening in the Ord. And then once smut was in Australia, screening in Australia. And to this day, smut is the largest part of our disease resistance screening program. But there was a big push of also using a clean seed. So as long as you start with clean seed that of a resistant variety, you have got a good management for sugarcane smut. There's also some fungicides which can give a short-term treatment for smut. So our management for this was really around those resistant varieties and clean seed. The next major disease I'm going to talk about is RSD, return stunting disease. So RSD is a bacterial disease. So this one, unlike smut, which has these nice, obvious external symptoms, RSD doesn't have any exterior symptoms. You can look at a block of clay, and it might look a little bit up and downy, but you're not really sure why. And often this can be because of RSD. So why does it cause this return? Why does it cause this stunting in the return? Well, it's a bacterial disease, and it's actually in the xylem. And what it does is it clogs the plumbing of the plant, which then restricts the growth that you can get. So on the picture on the left, you can see a heavily infected ratoon. And then on the right-hand side of that same picture, you can see an uninfected block or uninfected couple of rows. So it can cause very much devastating disease. Where did it come from? Well, I think this was accidentally imported in cane. It really is, it's spread a lot in planting material because it lives in the stalk, in the xylem, but it also spread by cutting implements or harvesters and in anything that's in infected xylem juice. So how do we go about managing this disease? So because it's a bacteria, it actually is quite susceptible to hot water treatment. The bacteria will, in effect, die at a certain temperature. So a hot water treatment and clean seed program is a good way of managing a disease. But how do you know it's there that you want to be able to do these hot water treatments, and how do you make sure that it's clean? Well, the important thing there is to do RSD testing. And also, because you can't see the disease, you do want to make sure that your equipment is sterilised, usually using a 70% metho, which I think everybody has a bottle of hand sanitizer or some metho around at the moment, absolutely. Don't use hand sanitizer, that for your own hands, but 70% is metho is kind of a standard sterilisation which you can use, but you can use bleach to also sterilise your equipment. The next disease we're going to talk about is pachymetra. So pachymetra, this is also a somewhat invisible disease because it affects the roots. So you can't really see the infection early on. This one, unlike the previous two examples, this is an Australian-owned disease. This disease is only found in Australia. And it is found in most growing areas, except the vertican, lucky vertican. So it's found, as I said, it's a soil disease. So it's found in the soil. The spores are in the soil. And the way that you know that you have a pachymetra problem, first you'll get some unthrifty growth. But if you can then test that soil, SRA has a lab where we can test and see how many spores you have per kilogram of soil. And from that, you can implement a management program. So by managing this disease, we manage it using resistant varieties again, but also a strong emphasis on quarantine and restricting your soil movement. Because obviously if it's a soil disease and you're moving around a large proportion of soil, there's a good chance that you, from a heavily infected field to a not so infected field, you could get movement of pachymetra into those areas. Last disease I'm going to talk about in this little section are rusts. So I've lumped these two together, brown rust and orange rust. They're both fungal diseases and they're both spread by wind. They're both presumed to have come into Australia from overseas. And in Rob's presentation last week, we found that it's quite obvious that varieties do have resistance to this. Brown rust had an outbreak on Q90, and orange rust, there was an outbreak on Q124. So big difference between these two rusts are generally the time of year, if you can't tell the difference between a brown rust and an orange rust. So generally the orange rust is in a humid summer weather generally. Brown rust is generally dry and cool nights generally. But it is possible to get brown rust and orange rust on the same plant. So if you really want to know how to tell these rusts apart, there's an excellent information sheet, which Sam can provide a link to in the chat box. It's called Know Your Rusts. And this will go through exactly how to tell the difference between a brown rust and an orange rust. There are some differences in the leaves which you can pick up, but the easiest or the best way is actually just doing a quick microscopic study. These are not the only diseases in Australia, obviously. We have many more diseases, many more major diseases around. But a lot of these diseases do tend to be found after particular weather events. So like chlorotic streak will be around after a flood event. You'll usually see more chlorotic streak. Leaf scald is very much sort of regional disease, as is yellow spot. And red rot seems to be sort of coming and going. We have a fairly high resistance to red rot in our varieties. So there are many, many other diseases. And SRA does have a field guide, which has all of the diseases you would ever want to know about, and probably some you don't. So going from these diseases which can affect the whole of the industry, I'm now going to talk about regional diseases. So just revisiting this map here. So looking at these regional diseases, there's a couple of common things about the three diseases I'm going to be talking about. One is that these diseases are all caused by a virus. The things about viruses in plants, at least, is that they are very hard to cure. You know, hot water treatment doesn't work. There doesn't seem to be any really good cure for any of these diseases. So the way that you manage them is by restricting the movement of the varieties around. So if you look at Striate mosaic is a virus disease only found in the Burdekin. So this is the whole reason that zone 2 is where it is. It is there because of Striate mosaic. So Striate mosaic, as I said, it's only found in the Burdekin around the Home Hill Air region. It's found in patches in the ground, and they seem to be very persistent, but they don't seem to move very far. So really, by limiting the material, the virus disease do travel in the stalk. So they are systemic, they can move in planting material. So by limiting the movement of the planting material from these infected patches really limits the movement of this disease. And it is very well managed in the Home Hill, Air and Home Hill area by BPS and SRA. Now, Striate mosaic, probably something that a lot of people won't see, even if it's there. It's got very subtle symptoms, but it can cause really severe loss in susceptible varieties in their returns. If we look back here at the next block, we're going down the state. This area from the bold red line across between Biosecurity Zone 2 and 3 down into New South Wales, this is the area where Fiji leaf gall is or has been a problem in the past in the central, southern, and in New South Wales. So Fiji leaf gall has only really been seen in these areas. Just checking my notes because I got this wrong yesterday. However, the Fiji leaf gall, so it's a virus disease. So therefore it is transmitted in the stalk material. It is transmitted in the stalk material, but then these plant hoppers, so this is the picture of a plant hopper there, not to scale, which then moves the virus between plants once it's established in an area. So NCO 310 was a very susceptible variety, and Rob talked about this last week with the rise and fall of NCO 310 in areas where Fiji leaf gall was very prevalent. Now I've got here that we have high levels of resistance in our cane, which is true. We have fairly high levels of resistance. We still do resistance screening for Fiji leaf gall. But I've got a could be eradicated question mark. Now, what do I mean by that? In the Central District, it hasn't been seen for about 20 years. In the Bundaberg, between 25 plus years, hasn't been seen. Around Rocky Point, hasn't been seen for around 10-ish years. And New South Wales hasn't been seen for more than 5 years. So is it still there? This is a question that we are currently grappling with. And we've done some studies in the Central region, and we're hoping to continue that to perhaps eradicate this disease from Australia. If we jump down to the final of these zones, if we look at sugarcane mosaic virus. So sugarcane mosaic virus, it's again a virus, and it is found really around the Bundaberg ISIS area and in Rocky Point. So then this is the reason for the zone line between 3 and 4. So sugarcane mosaic, it is again a viral disease spread in planting material, and this has a vector which is an aphid. So the resistant varieties that are grown in these areas have kept it very much under control, and the restriction of movement of material out of an area with mosaic to an area that doesn't has really kept it very much under control. Could we eradicate this? I think it would be a little bit more difficult because mosaic has alternative hosts. So unlike Fiji leaf gall, which can't easily jump into something else and sit there and wait for a susceptible cane to be planted next door, mosaic can jump into native grasses, native sorghums, corn. So it's a little bit harder to eradicate because you would have to do a very big treatment and a very robust way of getting rid of that virus altogether. So what can we learn from this? So common factors in our disease control, many of the major diseases are transmitted in seed cane. So really having strict quarantine for movement of planting material, knowing what you have, doing clean seed programs and cold soak long hot water treatment as a regular part of your growing can really control a lot of these major diseases that are transmitted in the seed cane. Now, what I have already mentioned then is know what you have. By doing RSD testing and soil testing for Pachymetra as well as for nematodes, which I didn't mention today, by doing these testing, you know what you have. And by knowing what you have, you can make educated decisions about what varieties you want to plant. Because really resistant varieties is the way that we have gotten a lot of different diseases under control. And you really do want to plant a range of different varieties to avoid epidemics. As Rob talked about last week, if you get a large number of a single variety, you are just waiting for an epidemic to happen. Talking about epidemics, the big question is, what are the next big threats? But actually, I like to phrase that more as, and how are we preparing for the next big threats? I'm going to talk about some of our high priority pests in this section and talk about some of the most recent research that we have done overseas. And a lot of this is around three major areas. One is, where are the threats? Doing some surveillance, like where are they physically, where are they in the world? And then looking at it from a diagnostic, will we know if it arrives and will we diagnose it correctly? So we need to have a very good diagnostic system. And then we have a whole other thing of preparation. Like, do we know how the Australian varieties will react to this disease? What can we learn from overseas in terms of their management strategies? How will we do short-term or long-term control? Could we eradicate it, or will it most likely not be eradicated? And what sort of yield losses are they? These are all important decisions that we take into account when we're deciding what overseas threats are the most likely to come in and cause the biggest losses. So I'm going to tackle our closest threats. Now, our closest threats are most likely to come from our nearest neighbours, which are Papua New Guinea and Indonesia. And as some of you know, we've had some very substantial work going on in Papua New Guinea and Indonesia for many years. So I'm just going to grab the pointer again, and I will just, for those who do not know much about Papua New Guinea and Indonesia. So in Papua New Guinea, sugarcane is only really, commercial sugarcane is grown at Ramu, which is in this area, kind of through here in this valley. So quite away from Australia, with a large mountain range in between. And in Indonesia, a lot of the cane, most of the mills are located on this island of Java, but there are sugarcane mills on a lot of these other islands in the archipelago. So I'm just going to talk about Ramu stunt first. So Ramu stunt is a viral disease found in Papua New Guinea in the Ramu Valley. Now, it's caused by a Tanui virus, and it is spread by Eumetopinia flappipes, and it's because it's a viral disease. Viral diseases are spread in planting material. Interestingly to us, and of concern to us, is that Eumetopinia itself has been found in the Torres Strait and on Cape York, but there has been no Ramu stunt found there. So the vector has made its way into part of Australia, only in that far northern region. When we conducted surveys in Papua New Guinea, we actually found that most of the Ramu stunt virus was found in the Ramu Valley. It didn't seem to have spread very far. A Ramu stunt can affect not just commercial cane, but it can also affect garden cane, chewing cane, or noble cane. So cane that's in people's gardens. So there is a large number of bridges that can be in PNG for movement of diseases. So although most Ramu stunt was found in the Ramu Valley, there was a variant of Ramu stunt which was found in Alatau. And I'll just pop back to this map to show you where Alatau is. So Alatau is down here. So this is a lot closer to Australia. So we don't think it has moved very far out of Alatau, but definitely has been seen there. So I mentioned the far northern area. The far northern area, so the Northern Australian Quarantine Service, they do a lot of surveillance through the far north and also into PNG and Timor. And they do look for Ramu stunt. And if they have any suspect of Ramu stunt, they send it to SRA, and we support them with molecular diagnostics, which we have developed. We have done some resistance screening at Ramu for Australian varieties, and in general, we had a pretty good level of resistance. So that bodes well in case of an incursion. So for those of you who want to actually know what this looks like, there's a very old picture of the first sort of outbreak of Ramu stunt when that happened. But you can see in the more modern pictures, there isn't that much really devastation of Ramu stunt. It seems to be very much that there's a lot of these leaf symptoms, which is like a mottling on the leaf, which can be confused with other things. And what we have here in the bottom left-hand picture is actually looking at one of our resistance screening trials in Ramu. So it can be very devastating, but it seems like we have a fairly good level of resistance. And where we do sometimes have symptoms on the plant, but they don't seem to be the extreme stunting symptoms. The next disease, which is a high priority disease in PNG, is called sugarcane downy mildew. So there are a lot of downy mildews. This is a sugarcane specific one. And this is caused by an oomycete, and oomycetes are the same family of diseases which causes pachymetria, but they're very different diseases. Downy mildew has very different symptoms depending on the host. It can infect a wide range of grasses. It can infect the wild sugarcane, the roadside cane, so our spontaneum, our robustum, and also our officinarum, as well as commercial cane and corn and sorghum. So it has quite a wide host range. The interesting thing about downy mildew is this is one of the examples where we eradicated this disease before. So it was throughout parts of Australia from the 1910s to about the 1960s, 70s. And so it was then eradicated by use of resistant varieties. Unfortunately, when we took our varieties to be screened in PNG, we found that there actually was a high proportion of susceptibility in our Australian cane now. When we did surveys looking for downy mildew, we found it mainly, again, in the Ramu Valley and the Eastern Highlands. But we found downy mildew on about 3 different species, at least 3 different species of grasses. And when we looked at those by molecular analysis, we found probably there's more variation there than we would really like to see. Corn, as I said, is an alternative host, so spread can be very easy. And as the same as for Ramu stunt, NARCs are looking for downy mildew on corn and sugarcane, and if they are in any doubt, they send us specimens to have a look at. What you see in this picture on the right-hand side is an infected little corn seedling up the top, and then at the bottom you see what's called jumper, which is a different symptom of downy mildew that you can see in really severely infected fields. If we jump now to Indonesia, now Indonesia, the biggest threat that they have there is a disease called street mosaic. And this is a virus disease, and this is found in most of the major sugarcane planting areas around Java. And it is spread, we believe it's spread in Indonesia mainly through infected planting material, because it can be asymptomatic, which means you can be infected and not know it. So it can look completely green. The symptoms are very similar to mosaic, hence the name. As I said, it was we think it's infected planting material, that moving that asymptomatic material around has caused most of the spread in Indonesia. However, in other countries, there has been very rapid spread, too rapid for what we would believe to be in planting material. So in Myanmar, there is been very rapid spread, and Kevin will be talking about some of the vector research that he's been doing there in the next seminar. Mosaic is one of these diseases that doesn't kill the cane, but it infects very wide areas, so you end up getting quite high yield losses from it. And there does seem to be very little germplasm resistance. Pretty much all of the Australian varieties have become infected. So we had a project in Indonesia funded by ACR, where we were looking at a few major things. We were looking at surveillance, looking at where it is, and that's how we found that it's basically everywhere where commercial cane is grown in Indonesia. But we also developed several diagnostic tests. For us, it's important to develop more than one test. One test for our incursions, for our own incursions to detect it early. The other one is for management in PNG, because, in Indonesia. I think that if you encourage people to manage the disease in their own country and they get it well under control, it will reduce the risk to Australia. So the project also produced a book, which is a field guide for Indonesian research in the local language and also in English, which is handy for them to be able to do in-field diagnostics just by looking at symptoms. So as I said, we looked at resistance screening. Unfortunately, most Australian varieties became infected, yield loss, and their management plan. If we look further afield, we get out of the close neighbours to slightly further afield. Now you will find street mosaic everywhere through here as well, through India, China, Pakistan, Sri Lanka. Street mosaic is everywhere. But what I'm going to focus on is actually one of the different disease range of diseases caused by phytoplasmas. So there are three major diseases caused by phytoplasmas. The phytoplasmas are travelling really quite quickly through this region. There are three major diseases: white leaf disease, which causes obviously white leaves, grassy shoot disease, and green grassy shoot disease. Now, of these, white leaf disease is the best studied, probably because it's the most widespread. It's a major disease in Sri Lanka, Thailand, China, everywhere through that area. Grassy shoot disease is a really major disease in India, and green grassy shoot is a major disease in Vietnam and is also found in Laos. So these are all related diseases, all caused by phytoplasma, but three different phytoplasmas. So we look at white leaf disease as an example of these phytoplasma. It is also spread in planting material. So moving around planting material is probably how it got into so many countries, just the unregulated movement of planting material. It does have a large number of different vectors in different countries. So in Thailand, there are 2 vectors which work at different times of the year. So you can end up getting quite a big spread of the virus, of the phytoplasma around or during basically all growing seasons. Most of the vectors are hoppers. And I think Kevin will probably talk about hoppers the next talk. But this disease can cause complete crop loss. So in Laos, Rob observed only a half of a tonne. So it's really devastating. We really don't know how Australian varieties fare to this disease. And it's really unclear whether hot water treatment can work. There's some anecdotal evidence, but not really very good studies so far. What are we doing about phytoplasmas? So we are developing new diagnostic tools, and I'll talk about those in a little bit. Our surveillance, again, we do that collaboration with NARCs, but we also collaborate with our overseas, with any overseas partners in these areas to see where the disease is and how it is spreading. Rob has done some in Vietnam, and when we were doing our surveys in Indonesia, we were also looking for white leaf because they don't have it and they don't want it either. We also keep very much up to date with this literature. However, this is really one of those areas where we need to do a lot more research, mainly a lot of it around varietal resistance, because this could be very devastating if it came into Australia. So don't panic. We have plans in place. Although this can seem very doom and gloom, what you need to remember is that we are prepared for a lot of these things. So we have incursion management plans. The idea is that we want to know more about these diseases and we want to prepare for their eventual, if they come into Australia. So we want to make sure we have good diagnostics, effective quarantine. We want to know how it's spread around, learn from other people about short-term treatments and long-term strategies, and really take into account, is this something that is eradicable or not? And then after it, if it's not eradicable right now, could you eradicate it later on with resistance screening, similar to what we might be doing with Fiji leaf fall? So don't panic. And if anybody wants to know more about biosecurity, we have a biosecurity plan for the sugar industry, which we're hoping to update within the next year. It's due for an update next year. One of the things I was talking about was surveillance. So I thought I'd just go through one of the projects we have on surveillance. So This is a very large project funded by the federal government through its Rural R&D for Profit program. And it is all about sentinel surveillance for agriculture with the snappy name of IMAP pests. So this is a very large project. It has all of the major RDCs involved and 16 partner organisations. So it's very large, cross-industry surveillance. The idea of this project, 5-year project, is to do air sampling, looking for pests and diseases through air sampling, through a very good diagnostic setup, using both morphological but then going into molecular diagnostics for rapid diagnostics, then being able to extend that information back out to industry for making decisions. So this is the aim of the large project that we have. Now, SRA is one of the RDCs involved. I'm the project leader for this in SRA. And our role is really threefold. We are looking at moth borers in Southeast Asia, which I'm not going to steal Kevin's thunder. He can talk about that in the next presentation. What we're also doing is modernising a lot of our diagnostics. So although I talked about a large range of pathogens, some of those pathogens we don't have very modern diagnostics for. Some of them take too long. So we want to make sure that we can get very fast, rapid, accurate diagnostics in place so that we can use that as part of our incursion management plan, but also for managing diseases within Australia. So we're looking at targeted test development as well as high throughput sequencing. And our third role is actually collaborating for the Sentinel. So this is a Sentinel. This image is actually of a Sentinel trailer, which it's called the hub, or we have a 6-metre insect suction trap, a 2-metre insect suction trap, and two 2-metre pathogen spore traps. And then you can see in the front of the picture, there's sort of an auxiliary trap there as well. So the idea of this, the flagship of the IMAP Pest project is really these Sentinel surveillance units. Currently we have 3, but we're looking at doing more modular ones, which may be better for some areas than others. So I don't expect you to understand or remember all of this. I won't quiz you at the end. But these are the list of diseases that we are targeting for improving diagnostics. And the ones I've circled here, these are ones that I've mentioned in our talk today. So you can see we're really trying to cover both diseases that we have in Australia, as well as ones that we don't have in Australia. So there is a lot more that we are doing that to really make sure that we have good diagnostic tests in place for potential or current threats. The really important thing about the IMAP Pest project is it is a cross-industry research. So this cross-industry group, you can see on the bottom of this slide, the large number of players we have in this space. So there is, for this first phase of the project, a target list of pests and diseases for the Sentinels and for diagnostics. Now, what we have done in SRA is we're developing additional diagnostics. So the aim is to bring those two together in the long run. The current project ends in 2022, and hopefully we'll be able to get a new project up so that we can really meld those two together and get the best out of the Sentinels that we can. So yeah, the IMAP Pest project is Rural R&D, and Hort Innovation, which is the second logo that you see on the bottom there, they are managing this project. Our final thoughts. Firstly, I'd like you to think that almost all of the diseases we have were exotic at one stage. And, you know, we've done a really good job of managing sugarcane diseases in Australia. However, we do need to prepare for these major overseas threats. We really need to have accurate diagnostics. We need to have early detection. We need to have extension, training, and post-incursion management strategies. And a lot of this is really facilitated by actually going and doing the research overseas. It's the only way we can screen our varieties for exotic threats. And the take-home message really is preparation is key to managing these diseases. So I've just got one more slide, a call to action, as the kids call it these days. What can I do? So if you want to have any more information about any of the diseases that I've talked about today, or Rob has talked about, on our website we have information guides, information sheets, and we do have field guides as well, basically little ute guides for our major diseases in Australia. If you want to know more about the IMAP Pest project or see what it looks like, some of the delivery of the output that we are getting from that project so far. Not much sugarcane specific stuff on there yet, but it can give you a taste of what's going on. You can look at the IMAP Pest website. If you want to delve into biosecurity and exotic threats, Plant Health Australia has incursion management plans, a biosecurity manual, and also a farm biosecurity manual available. We have hard copies of the farm biosecurity manual available as well. And if you want to know more about the biosecurity zones, movement of material, or anything like that, you can have a look at the Biosecurity Queensland website. So this is just a thing from Plant Health Australia. They say, look, be alert, and call an expert. So the other thing that their tagline is, have you spotted anything unusual? So if you spot anything like that giant purple bug with yellow spots on it, you can call the Exotic Plant Pest Hotline on 1-800-084-881, or any of the SRA pathologists are very happy to help with anything that might be unusual. Just finally, thank you very much for your time, and that's the end of my presentation, and I'll hand back over to Sam.
Thanks very much, Nicole. That was awesome. I put a link to a survey in the chat box. Your feedback is important to us, and I encourage you to complete so we can improve on our presentations and webinars. So Nicole now has time for some questions. If anybody would like to either unmute their microphone or type anything into the chat box. Just give it a minute or two and just give you an opportunity to type any questions in. Okay, we've got a question here, Nicole. What's the current status of Ramu stunt in PNG?
So Ramu stunt is very dependent in Ramu of the weather, of the amount of vector that's around. So I think they have had quite severe drought. So it has been found less and less. But also they do screen their varieties for resistance. And so by planting the more resistant varieties, it definitely has been, I guess, less of an issue throughout the entire of the Ramu Valley or through their production area. But there are definite pockets where they do get it coming back every year. So I guess it's being managed, but also the amount of sugarcane that's being grown in Ramu, and I'll let Rob interrupt me if I'm wrong here. The amount of sugarcane that's being grown at Ramu has been on the decline. So there seems to be less sugarcane to get infected. I don't know if you want to add anything, Rob.
Yeah, I think it was Salam who asked the question, so he'd have some background knowledge here. I think there's one variety, I think it's B72, that was getting a bit of Ramu stunt, but it's not in any way causing too much yield loss. They have much bigger problems with moth borers and also with weeds. So I think it's not devastating the crop there at all. It's just hanging around at this point in time.
Yeah, I'll also add for your information, Salam, I don't know if you know that I mentioned earlier in the talk that smut was only not found in 3 places. Well, now it's down to 1 because smut is also now in PNG. The only place it isn't now in the world is Fiji. So they definitely have a lot of other problems in PNG.
Yeah, thanks, Nicole. I just meant to say that I found it a bit difficult to find Ramu stunt in PNG when I was working there.
Yeah.
So, but that doesn't mean anything. It might just mean that it's dormant, or and it might as well just come back any moment, really. Thanks, Rob, for your comment too.
During our research, we also found that it was difficult to find sometimes, mainly because the resistance of the varieties seems to be, there's a lot more resistant varieties being planted. So you don't tend to get that dramatic stunting as much anymore, only on a couple of varieties, which are not being planted, obviously, because they are more susceptible. So you end up just getting that leaf symptom, which makes it a little bit less likely to spread around.
Okay, thanks, Nicole. Our next question is from Phil. You mentioned most Australian varieties are susceptible to mosaic streak, but have there been any resistant ones found, either Australian varieties or Indonesian ones?
Yeah, so we don't have a lot of information about Australian varieties yet. As part of our project, we did send some Australian varieties into Indonesia, but we have not yet got the results from the resistance screening for those. What I can tell you is that most of them did get symptoms. And this is also what's happening in Myanmar as well, when there was some Australian varieties there and they all got infected very quickly. There are some varieties in Indonesia which do not show symptoms. The virus is a bit tricky though. Sometimes asymptomatic plants can still have the virus. So I'm a little wary as to whether they are really not infected. But there definitely is at least 3 or 4 different varieties, I think, in Indonesia in their breeding program, which look to be good candidates for being resistant. And the next question, which is follow-up for that, I'm guessing, will be, are we trying to get them? And the answer to that is yes, of course. We're trying to get them to have in our back pocket in case of an incursion.
Thanks, Nicole. A question from Priya. You mentioned phytoplasms are a possible threat. How is it managed in the countries which have it?
That's an excellent question, Priya. A lot of areas, it seems to be different in different areas. So Sri Lanka, for example, they have a hot water treatment program, which seems to be very good, but they also have a disease resistance screening program, which seems to be good. That hot water treatment doesn't seem to be effective elsewhere, so not really sure what's going on there. So, but resistant variety screening is definitely the way that a lot of places are managing this disease. The other way of managing the spread, so they start with a clean seed program. So in Thailand, they are doing they've got a clean seed program to make sure that they're planting uninfected material. They do, I think they do a high proportion of testing, as well as I think they use a tissue culture system or a bud system for putting out lots of uninfected plants that were resistant. But they also know what the vectors are, so they do some levels of vector control and vector monitoring to try to keep the outbreaks under control. So they're sort of the main things, is really looking at resistant varieties, clean seed, and vector control. They're kind of the 3 main ways. I don't know if Rob has anything he wants to add to that.
No, I think you've touched on the main points, Nicole. I think in some countries it's not managed well at all. And I think while they have some of the major management strategies, it's not very well coordinated at times. Graham Cripps is on the line. He would know very well from Vietnam how there's a battle trying to control it. I think we have the tools should it come into Australia. It's just a question of applying it, methodically and in a very stringent way.
So just to continue that, it's Priya here. Good morning. So are we testing Australian varieties like you did for mud in one of these countries?
No, not yet. This is an area of future research that the pathology team is very keen to do. We think it's an important stick in our important gun in our arsenal, really, against phytoplasma, is to know what a resistance of our varieties is. So no, Priya, we're not doing that currently, but it's something that we are it's very front of mind for all of us to try to get the funding, really, to continue or to start that research.
Thanks.
Okay, Nicole, we got a question from Megan McKenzie. 2 questions. How has COVID-19 affected the work in other countries? And how had advances in digital technology impacted on diagnostics and disease management?
Okay, so the first question, I think the lockdowns in a lot of countries are definitely affecting the normal research, similar to here, restrictions in movement. But if you're interested in that area, Megan, I would suggest you go to the ISSCT had a webinar a while ago, and hopefully Sam will be able to find the link and put it in the description box. So ISSCT did a whole 2-hour, I think, webinar about the effects of COVID-19 in different countries. So that might be the best place for you to get information about that, because I only know from talking to my friends overseas, and probably a more objective opinion would come from that webinar. So I'd suggest you go and look at that webinar. How has digital technology, Sam, could you repeat that second part of that question?
How had advances in digital technology impacted on diagnostics and disease management?
Right. So this is a really growing area of research, using digital, mainly a lot of digital imaging for diagnostics. So the IMAP Pest project is looking at using a lot of digital imaging for pests, for borers and things. So they have these traps, auxiliary traps. So this is work done out of Western Australia on auxiliary traps, which have a high resolution camera attached to them, and it sends back images to a lab that can be analysed. And there's a lot of work that we're kind of very interested in for doing similar thing for diseases, because some diseases are very easy to diagnose visually and others are not. And it's an area of research that, you know, we're quite keen to get into. And it's definitely movement in that area. And in other crops, it's much more advanced than what it is in cane, especially, you know, the overlap of the digital imaging with machine learning and is really taking off in other areas. So similar, like precision agriculture and things like that. So it's an area of current research, I guess. And I really want to get into that area, so that would be excellent. Yeah.
Can I make a couple of comments too? Is that okay?
Of course, Rob.
Yep. The first one, you know, what you were saying about overseas, it really has shut down Australian researchers travelling. And, you know, in the past we've had much travel to PNG and Indonesia. So it's COVID has really restricted any possibility of overseas research projects going ahead, and it had a big effect. And Kevin might talk a bit about that next week in relation to pests. And as you said, Nicole, you know, digital technology, I think, has a great potential for assessing leaf diseases across whole regions, and even assessing the resistance of canes to leaf diseases. And in fact, Muyi, who I think is listening as well on this talk, has a small innovation grant to look at the possibility of digital technology. So yeah, I think it's a great field with excellent possibilities.
Okay, thanks. We are close to finish time, but we have 2 more questions. How many Australian varieties are susceptible to downy mildew that are tested? Any % figure?
I think it was about 50%. Is that right, Rob?
Yeah, that's
Yeah.
right.
Yeah. So before we started the research in Indonesia, in PNG, we estimated around about 80% susceptible. And when we did the testing, it looked like it was about 50%. But bear in mind that research ended, those screenings ended in several years ago. So of the current cohort, we're not really sure. Would be around the same. We want to aim for about 20% susceptible. That's where we would like to be.
Okay, and this is our last question from Hajid. Other than soil applied systematic insecticides against moth borers, what strategies are used in other countries to manage them? I know BT cane is being tested in Brazil.
Well, this is a perfect opportunity for me to handball to Kevin.
Thank you. I was in the US last year, and they have a thing called the Mexican rice borer, which has gradually spread up from Mexico through Texas to Louisiana. And one of the ways that they go about managing the pest is crop scouting, surveillance with pheromone traps. They only apply insecticides when absolutely necessary. So they basically look at the number of adults that are caught in traps. They found a very good correlation between the number of adults and the number of larvae that attack the cane. So when they spray, it's very judicious spraying. In Texas, they do a lot of aerial spraying for rice borers, which they actually found that when they did that, initially they were doing it 12 times a year. So that was having a dramatic impact on the natural enemies. So basically they have an integrated pest management approach, which is judicial use of insecticide, proper monitoring and scouting. And the other thing that they do is varietal screening for resistance. So it's a whole gamut of different approaches. Yeah.
I think from our research in PNG and Indonesia, there's a lot of use of natural enemies or growing up the parasitic wasps and things like that as well. That's part of the IPM strategy as well.
Okay, so a reminder to all about our survey in the chat box. We would love to get your feedback. The recording from today's presentation will be available on the SRA website and will be shared via our next e-newsletter. Thank you very much to Nicole for presenting today and for Rob and Kevin assisting with questions. And we look forward to seeing you at our next webinar, which Kevin will be presenting at on the 26th of August. Okay, thanks everyone.
Thanks, Nicole.
Thank you.